Hello everyone and welcome to the Math Bender. I'm Adnan Zaidi, and in this last session on household mathematics, we'll discuss compound interest. So previously we talked about the simple interest where initial principal amount that you invest or loan from somewhere does not change throughout every year. Just the interest is being applied on the same amount, but you invest some amount in a bank to get interest after some years, 7 years, let's say, and the interest is compounded annually. So, which means after certain percentage that is being applied on that principal amount that you had invested, the amount will increase and the rate will be applied on the added principal amount. So, every time, every year, if it is compounding every year, so which means the increased amount on principal now will be taken into account rather than the initial one. I'll give you some examples here. So first of all, compound interest is A is equals to P 1 plus R over 100 to the power of T, which is time. R is rate, P is principal amount here. So it's principal amount. A is the final value after the interest has been added. R is rate and time T is time. We rather stick to the compound interest new formula, that is this. Alright, so let's see some of the questions here. So how much would you have to repay on a credit debt of £3,500? So this is your principal amount. So first make the data of it. So the debt is, which is your principal amount, which is 3,500. After 2 years, so time is 2 years. If the interest rate is compounded annually, so rate is 19.5 per year. Annually means per year. So this means that the interest is applied every year on the principal amount. So after the interest is being applied, the initial amount, which was 3,500, is now added with the interest and new principal amount comes into play. So every time the principal amount will be changing in compound interest. So after 2 years, the value of that debt will become 3,500, 1 plus rate, which is 19.5 over 100 to the power of time, which is 2 years. So if I calculate it, $4,998.1. So this is after 2 years the value of the initial debt, which was 3,500. Now for part B, compounded half yearly. Now I told you that our rate and year has to be same. So let's make the data first. So data principal is the same, which was debt. The time. So how many half yearly is in, let's say if we take out half yearly, so the rate, first thing, the rate will be, this is compounded half yearly, so it will be initial, the rate is actually 19.5 over 2. So this is annual rate, and if I divide it by 2, it gives you the amount of interest, so which is going to be 9.75. This will be applied every half a year. And now time, since I've converted the rate, annual rate, into half year rate, now I'll convert the time as well into. So the time, total time is 2 years. So convert it into half yearly. So how many half yearlies are in 2 years? So in 1 year, there are 2 half years. So in 2 years is going to be 4 half yearlies. So A is going to be principal, which is 3500, 1 plus 9.75 over 100 to the power 4. This is going to be 5077.92. Note that if the compoundation is in fragments of smaller time or nearest time, then there will be the in final value will be bigger. If the same rate would have been applied for monthly, we would have divided 19.5 by 12. We would have taken out for 1 month, and then the power for 2 years. So 2 years, how many months in 2 years? So we would have taken 24 instead of time. Now taking another question into account. So Samuel invests 1500 in an account paying 1.9 per year compound interest. So let's take the data for Samuel. So principal is 1500, rate is 1.9 compound interest per year. Same goes for Nina. The principal amount here is as well 1500, rate is also 1.9 but simple interest. They each leave the money in their account for 5 years. So the time they both left the money was for 5 years. So now Samuel had a compound interest and Nina had a simple interest. So first find out the simple interest. And you have to find out at the end of 5 years how much money does Samuel have in his account than Nina has in hers. So interest is going to be P, which is PRT. We know the formula, PRT over 100, which is going to be 1500 times 1.9 times 5 over 100. So interest is 142.5. That's the initial only interest price. So the total price, the total value that he has in his account is going to be principal plus 142.5, which is going to be after 5 years going to be 1642.5. Now for Samuel, it's A is equals to P 1 plus rate over 100 to the power of t, and this is going to be 1500 1 plus 1.9 over 100 to the power of 5. So this is going to be plus adding 1 to it, and then the whole power becomes 5 times 1500. So it's going to be 1648.01. Note that this formula does not give you the interest alone. It gives you the interest added with the initial principal value. So Samuel has 1648.01 minus 1642.5, and if you subtract whatever the value that you get, this is more amount that Samuel has in his account than Nina. Let's see the last question of the day. More or less every question is exactly the same, so you just need to have an idea how to approach these questions. So Anton invests 1500, so that's your principal amount, 1500 in another account. The account has a compound interest of rate P per year, so rate is P% per year, that's the compoundation, at the end of 3 years. So time is 3 years. So the final value is 1598 in his account. How much time it had taken? You have to find out the rate. So after 3 years, This is the amount that he has in his account. So A is equals to P1 plus R over 100 to the power of T, which is 1598.85 is equals to 1500. I'm just placing the values. P over 100, since the year time is in year and the interest is as well. So the rate, if both of them are in year, so I don't have to change anything there. Power 3. So 1598.85 over 1500 is equals to 1 plus P over 100 to the power of 3. So the value becomes, I divide that value with 1500 dividing 1500, but both sides going to be 1.066 equals to 1 plus P over 100 to the power of 3. Taking cube root both sides is going to be 1.02 is equals to 1 plus P over 100, and now subtracting 1 from 102, minus 1 is equals to P over 100, and then times with 100, which gives you P. So equals to 2.15. I mistakenly wrote P there. It's actually R. The values are all correct. It's just that this is all R rate. So don't confuse yourself with that. It's just the rate. So this is all about compound interest, and we're done with our session related to household or financial mathematics. We'll come up with some other lectures in our next session. Until then, take care. Bye bye.